Bloop. So, by popular request, we're going to do the last two questions of 12.5, and I haven't even looked at them, but they're going to be great fun. So let's do that. I also want to get some blank paper up here. Okay, and back to this. So, find the parameterization of the line with this and that, go. And I'm like, what? So I think it's when they're intersecting two planes. So like first off, I need to like draw what that looks like. So I got one plane, and I got this other plane. I'm gonna try to do a different color where it's kind of like coming in all wonky like, maybe something kind of like this, and then you know what I mean, something like that. I'm just making something up. There's the other plane, but they're intersecting along a line. Okay, there's a line out there where these two pieces of paper are touching one another. Okay, so yeah, in a way, two pieces of paper, and I'm not like trying to go through each other, but just like touch your tips together. If you touch two pieces of paper together, wouldn't that like be on a line, right? So that's the line that they're wanting. So essentially, I'm saying like this equals that, right? Now hold on for a second. Variables, yeah, but only two equations. So how many results? How many answers am I going to get out of that? Infinite. Infinite because of one variable missing a bit, basically, right? But watch this. The answers all have one variable, t. T. So basically, I'm going to take my x, y, and z and go do some math, and then t pops out. That's the idea. Okay. Now, how do we do that? I don't know, but but it sounded cool on paper. I'm gonna go with the easy route. I got X by himself, and he's really nice and pretty. Let's move everything else over, and that way we can get X equals something or other. So I got X is equal to -1 minus 2y plus 4z. I just chose the easiest one up there. That was the easiest one, right? Now I could take this and I could plug it in right here. So I got -3 times all this stuff. And then minus 3y plus 6z is equal to -3. Okay. And I don't know, distribute. So 3, 6, -12. Now you should be yelling at me here in a second. Hey Chad, I don't see only one variable. I see two. I know. We haven't yet solved it yet. That's the thing. So I think that there's a way to get to this. Combine like terms. Unless y'all have other ideas, you'll tell me, okay? I'm just trying some stuff out. Positive 3y minus 6z equals -3. Did I mess up something? Did I or did I? Oh, I haven't moved it over yet.
My bad. Sorry.
No, actually, it's a good idea. Let's do that. I was going to put 6 because you said 6. Exactly. Let's go ahead and move that over. Because I said combine like terms, right? So that's exactly right. I'm going to move the z over. I don't think I like the z over. Nope. I'm going to move the y over. And you'll see why I want that here in just a second. Is that okay so far? Just moving things around. If I divide by the -3, so then I got y is equal to, right here, it would be a positive 2z minus 2. Okay. Bam. Awesome. What'd that give me, Chad? Nothing yet. But I boxed it in because it's so cool. Are y'all, at least at this point, y'all understand the right? Solve for something, plug it back in, solve for something. Okay, cool. What if I plug this in right there? Whoa. Why are you doing that, Chad? Because I already have x equals. And I hope it's going to look pretty. So if I keep solving that, da 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 da, da 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 da. Oh, wait! Look at that! Look at that! So x is equal to 3? I don't like that. That's too easy for us. We got to scrap this problem, start over. It's way too easy. Yeah. Can you already tell what the answer is going to be? Look around. What's the only one with a 3? Like literally a 3. Yeah. Yeah. And watch, it's going to be wrong or something. Okay, fine. Fine. So was lost because this is multiple choice. What if I had to type it by hand, right? I want to keep going because I need to have it with the T's. So there's a key moment coming, but I'm glad that we at least can get the answer. So what I'm going to do is I'm going to rewrite what I have. I got x is equal to 3. I've got y is equal to, 2z minus 2. And I got to know, what is z equal to? What is z equal to? Look, we got those two guys. What's z equal to? It's way back in the... What? It's one of those dependent matrices. Y'all aren't picking that up. Okay. I'm like 9, section 3. Actually 2. Question number 4. Y'all don't remember that one. Leaving it wide open. I know. I'm playing. It's because I teach all the time, so I remember these things. It's a dependent matrix because z equals z. I don't really know what z is going to be. I don't know, but that's a proper way to do it in a way. So what I actually have is, in a way, I have something kind of set up. It's really, really close to getting the answer. I now need to establish a t. And if I have a t equals something, I can kind of like put it back in and it should be fine. And this is where we have to almost like create something out of nothing, okay? So watch this silliness for a second here. What if I said t equals z? What if? Then I could take all this and mush it into, well, x equals 3 plus 0t. Y is equal to -2 plus 2t. And z is equal to 0 plus 1t. And those would be my answers. Now, I know that I put the zeros in and me from being able to get the right answer very quickly. Do I have the right answer? Doesn't look like it. That doesn't look the same, Chad. But it still works. And that's the fault with MyMathLab, where it's multiple choice. I have to choose one. And I have to choose the best one. Okay, but there are other options. Okay? All right. Well, how do I get to their answer? Let's say if it wasn't so easy at that one time, right? Well, look around for a second. We're really close. We're very, very close. See, so my x is 3 plus 0t, and their x is 3 plus 0t, essentially. So this is going to be my, and this is they. Bad English, but it works. Y equals, mine is -2 plus 2z. Theirs is y equals -2 plus 6t. Keep this in mind. Here we go. Z for me is 0 plus 1t. Their z is 0 plus 3t. Do you see the similarities? There it is. Yep, they multiplied it by 3. Where's my colors? Give me my colors. Oh, thank you. That was their arbitrary decision. I think 1 would have been fine, but they wanted not 1, but they wanted 3. And so therefore we would have, well, 0 doesn't matter. This would now be a 6, and this would be a 3. This would be a 6, that would be a 3. And there you go. Got it. So yeah, that y, I would say x, but that's a math joke. But I don't know why they chose that. But again, that's why it's multiple choice here, because now we're having to go back even further. We had an answer. That's what I'm trying to say. We had an answer, and they said, no, it's not good enough. So yeah. There's a multiple choice problem where it shouldn't be. It should be a short answer. Type it in kind of results. Good? Better. Shrug. Yeah. You're good? Bro. Maybe. They might have chose 3 for one of those reasons. They might have done it differently than what I did. They might have literally said, oh, that's a 3, let's do a 3 here for no reason. I don't know. Like, it would make no sense, but what they did is not what I did, apparently. But that's okay. My answer's still legit. Okay. Cool. Good? Oh, let's do the other one, the last one. Okay, let's do the last one. I'm going to refresh this page. Should I do that or should I wait? Refresh? We're good? Refresh? Bye-bye. Okay, so 2 different planes have an intersection of this. So they already gave me the answer. Write the equation for each plane in the form of this. Okay, ouch. Okay, ouch. And so the reason why is because, like, here, let me make a line. And I'm going to make a plane that comes off of it. I'm going to make another plane that comes off it. Literally, I'm saying 2 pieces of paper are touching. Where's that line? They defined the line, but they didn't define where the pieces of paper should be. They didn't define where the piece of papers should be. They didn't define where the piece of papers should be. Do you see how many pieces of papers we could have? Infinite. So yet again, this is why it's a multiple choice problem. We're going to pick one that works the best. Okay. So 3 of these don't work. 1 of them does. Just with that knowledge, we could probably work backwards. And what we could do is like plug these in and see if we actually get the same results. I'm going to say if that was a test, if this is on a test, I don't know if I don't think it's going to be a test. If that's on a test, then I would just start doing the backwards method. We have the answer. One of these is the answer. Let's plug it back in and see if it's going to work. Okay? Totally cheater, but you know, that's what it works. Way to do this because it really is infinite answers. And they go ahead.
Couldn't you for this one solve for t and then plug in t equals t like 2 equations
Yeah.
and then solve for the either xc or yc?
Yeah. But then I would get like 1, and then that's still arbitrary. I think I'm going to go the multiple choice route, unfortunately. So one of these is the answer. And yeah, we're going to just plug it back in. So I got x plus z is equal to negative 15. And then I want to see, does that even like work with the line? Like if that doesn't even work with the line, then we got a problem, right? So let's start with this to see if it works. I have an x, I have a z. Let's plug them in and see what we get. So I've got negative 7 minus t, and then plus 9 minus 4t is equal to negative 15. And I could solve, right? I'm already thinking ahead. What am I doing? Very, very silly, Chad. Okay, it's okay. 17 divided by the negative 5. So I've got t is equal to 17 over 5. Okay. Let's try the other half of this and see if that works. So I got 4x plus y is equal to negative 36. I have an x, I have a y, let's go. So do I get the same thing? Am I getting close? Could I plug this in and it's still true? All these are good questions. I'm actually getting super nervous right now about this. Distribute, nothing to distribute there, negative 28, minus the 4t, minus 8t. No. Are y'all watching me? You're like, yeah, I'm watching, but I mean, I don't want to help you. Cancel. Negative, what is that? Is that negative 36? Equals negative 36? Okay. That's a check. I'm thinking t-values work with that one. What t-values can I plug in to make this work? Any, all. What t-values am I going to use for this line? Ignore this thing. What t-values can I plug in there? Oh, it's a line all the way back and forth, right? What I'm guessing, what I'm thinking is that what we've discovered is actually a good thing. I think that this guy right here is saying all t-values work. I'm nervous though. I'm still thinking like, do y'all know there's the, I don't know if you ever go to YouTube about these silly things, but they say, oh, we can solve that, 1 equals 2. And then they go through and they do some math and it looks fancy and it's actually, oh, look, 1 equals 2. But what they do is they come up to the stage like 0 equals 0. And then they start like multiplying both sides by something. And then they like cancel your zeros and 2 equals 3. Ha ha ha! It's like, no. And that's that kind of beware, watch out kind of, I'm nervous. But it doesn't make sense in reality where I'm saying any t-value works. So let's just go forge ahead for a second. I like this guy. This one technically only works now at one point. It's like there's a line going on and then it hit the plane and then it kept moving. Is that a useful plane for creating the line or just colliding with the line, you see? So what if I take this guy as what I want? I like this guy. Do we have anybody else like this? This guy? So let's try this one out and see if we get a similar result. I'm going to refresh. So yeah, let's try the y plus z is equal to 1. So I'm going to plug it in. We got negative 8 plus 4t. Got a 9 minus 4t is equal to 1. Look at that. As expected, right? As expected. So either we're both right or we're both wrong. Something's going on here, and I want to know. I'm going to test it. Cool. So there it is. This plane work with that line? All of them. How many t-values work with this one? All of them. So then that is the guy right here. They're literally creating it infinitely, up and down, both of them. Cool. See how I needed multiple choice to get to that, though? Right? If they said just create a plane, we could definitely create a plane. Create 2 planes. I could create 2 planes, but they would be like, I would do a silly Chad thing. But yeah, this would. That's just how it is.
So this has very limited practical use because you have to have the answer to be able to find.
For my math lab, if we wanted to create a plane, they just said find a plane that works. Then we have a line, and I want to have a plane that's kind of like touching it all the time, right there. I could take this orthogonal to the line, and then I can do a cross product, and it's coming out of the page here, where that's my normal vector for the plane itself. Done. And then we define the plane. So you would have your line. You would say 90 degrees from the line. So we got 2 vectors now, right? And then cross product, we're out of here. So that's what we could do.
What we just did, it requires multiple choice.
because they want two planes. Yeah. And I can find a second plane, and it's going to be silly. It would be the normal vector, and it would be the original creates a plane right here. If you can see it, like I'm trying to come out of the page here. Like it's literally, like if you're looking straight down, it looks like this. Like it's like it's a 90-degree angle thing. Can I create a second plane? Sure. Here, let's do a third plane. Let's do a fourth plane. Like let's go like 45-degree plane. I can do those things, but which one are you looking for? Very good. Yeah. So my math lab is definitely hindering us, but it's, well, it's, yeah, I know. Yeah.
It seems like it's doing math for almost just for math's sake.
So back to the workbook. Any other questions though?
No.
Okay. Okay. Good. And if y'all have any other questions along the line, please show me, because
Honestly, I was just trying to figure out what they were
yeah, well, I mean, me too. I don't always understand either. And now I'm going to have that not with this problem, but with the next one here in a second. So, so we're back into what we were doing. We just took a derivative, and that felt really nice. We love derivatives. And this guy here is wanting the same thing, right? See how they're wanting velocity acceleration? So we're just doing derivatives again. So that's nice. So we have our R. They want V, and they want A. And so, what is V equal to in relation to R? R what? R prime. And then this one would be? Yeah, R double prime, exactly. First derivative, second derivative. So let's do that. And y'all are going to help me a little bit, right? What would be the derivative of that thing? Sweet, sweet. And then J?
2 minus 36t.
32t?
32, yes.
Okay, cool. No, we're good. I get you.
Yeah.
So A,
0,
and then?
32.
Yep, very good. Why negative 32? What's going on there? Have you seen that before? Gravity. Yeah, but this is in feet per second, so
Oh, yeah. 32
squared technically, but yeah.
What a metric system.
Yeah.
Numbers not arbitrary.
Yes. So we have these two, and they say, what's the angle between them? Don't we have a formula for angle between two vectors? And I'm trying to remember it. I think it's u dot v, magnitude of u, magnitude of v, like that. You're like, wow, Chad, you just know these things. Well, I mean, we've used it before. It's one of the more common ones to the class. So we already have our two vectors, and they're two-dimensional vectors. So that's kind of nice. So then what is v dot a going to be? What do we get out of this? 0. Plus, and then this guy is... Very good. Let me redo that thing. Negative 32 to 32t. Negative 64. Hold up. I got this one. Okay. 2, 4, 6, 8. No. 2, 4, 8, 16, 32, 64, 128, 256, 5, 12, 10, 24. Is it 10, 24? 32 times 32? Back me up, guys. Where's my Desmos? Give me my Desmos. 32 times 32. Boom! That's what programming will do to you. When you program enough, you just know powers of 2 really well. Yeah. Anyway, so this is my dot product that I'm going to be putting up there. But it doesn't matter. Look, I'm going way too deep into this problem. What is the small thing that I forgot to see? Makes it so much easier. Yes, right there. So much easier. Because then I don't even need this. There's my dot product. When I try to find magnitude now, so I'm going to do magnitude. I'm just going to, what? Go ahead. At t equals 0, I could just kind of like knock that dude out. So 2 square root of 3 over 3 squared plus 2 squared. Magnitude for this guy. That's a funny one, right? I don't know what this answer is, but I can definitely tell you this one. What's this one? Yeah. So we got a negative 64 in the top. Let's start doing this. So we got arc cosine of negative 64, and I got a 32 down here. And now I just need to know what this guy is. What I recommend is to do this in. Oh, you already know it. Do it without the square root, and then you can kind of see what's on the inside of the square root. And now I square root it, and I would get 4 over square root 3, basically. At least I hope so. So 4 over square root of 3. And that's what I'm going to put in my formula here. Arc cosine. Let's see if I can get the right answer finally. 4 over square root of 3. Oh, well, that's nice. It's nice when it comes up to something like legit, you know? Oh, why are they mean like that? Yeah. It is nice degrees. So, to go to radians, we don't want to just do that. There's an easy way. If there's something easy like this, couldn't I just like unit circle that thing, right? 5 pi over 6. And so that's my answer. But if you want to do it all in the calculator, it's still very possible. And I'm pretty sure you know this trick. If you divide by or multiply by 1 over pi, see? Oh, you didn't know that? You went,
Right, because I was just, sorry.
Oh, but so did you know that?
I remember Ryan mentioned it a few days ago, but it clicked into my head till after you mentioned it. You know, I usually just divide by pi.
Right. Yeah, exactly.
It's the same operation.
Yes. You got it. That's exactly right. It just makes it easier to convert. Cool. Oh, did we get it? I never check here. Yeah, we got it. So that's good. Okay, cool. Sweet. Good with that? Fun times, right? The next one I don't know what to do. So I went and looked at it, but then I just didn't read very well. So we're going to read together. Scroll. You're good. Good over there. You're looking down. I'm just let it go. Okay. So I have to read this one very carefully because I don't know what they're trying to say. So a tangent line of a smooth curve at a certain time is the line that passes through this point and is parallel to this thing. There's a lot going on already. The velocity at that point. Okay. To find the parametric. Okay, easy. Super easy problem. Super easy. But like, what in the hay are you trying to say, right?
Sometimes a lot of these problems can be like, wording is super precise.
Yeah.
But also very vague. It's like,
So, when they say, and let's talk about smooth curves. If you go back up to the top, this is a smooth curve right here. Okay, so it's just like and like it can actually pass back through itself even. So like we think function, and it's not like that anymore.
so it's basically
Continuous,
it doesn't come to a sharp point or
smooth and continuous. Yes, smooth and continuous is what we're looking for, which is very good. So we have this curve, which, I mean, it's always easy to just do some kind of lumpy thing like that is fine. And then we make a point right here, okay? So there's my point, and this is at t equals t naught. But, like, essentially, it's just that's where my t is. This is at time t naught, t0. It didn't look very good. Let me try that again. So, like, maybe over here we got t equals 0. Over here is like t equals 1, but this is like somewhere in the middle or something. I don't really know. We don't really care. At this point, they're saying that there's the velocity, and we want a line parallel to it. So what is the velocity at this point? Is this guy, right? That would be my velocity. If nothing else changed, like space, you got to think like space, and you're swinging this thing around, and yay, and then you let go. Where's it gonna go? And it would keep going and going and going and going and going and going and going forever. Space. You got to think like space. So that's the velocity is where you would be going. Okay. So I'm wanting a line that's parallel to it. Well, here I've already done half the work. Yay! There's my line. So like literally, we're just gonna copy paste what's going on there. Okay. I need to find the velocity vector, and that is going to give me my slope. Those are the slopes of the line. And then the intercept is basically where I'm starting. Close enough? Let's try it out. But I have to erase because that's like too much there. Okay, so this is my R. Let's find V. So that's R prime. What would be my derivative?
-3 sine t.
Cool, cool.
Then next is 2t minus 3 cosine t.
I agree.
And then 12e to the 3t.
Excellent. Very good. One small thing that we don't take derivatives in Cal 3 all the time, right? Come on. That 3 is going with the 4, but that's a 3t, but the t disappears because that's the derivative of it, right? It's the derivative you're multiplying by, right? Okay, very good. Very good. So this is fine. Now, they say that t naught is 0. Oh, easy. Makes things so much easier, right? So we're doing r prime at 0. What's sine of 0? Boom. 2 times 0. Cosine at 0 is? Very good. And then this whole thing turns into a? Very good. Very good. And so this is my velocity. This is my slope, essentially. So let me just real quick finish that up. 0, -3, +12. So that's my slopes. I still need my intercepts, which I get from up here. So I'm going to just say R at 0. Plugging in a 0, I get a? Uh-huh. 0. Oh, 0, yeah. And then this guy? 4 once again. Very good. So this is my point, I guess, and this is my slope. And so my lines are going to be x is equal to x naught plus at, y is equal to y naught plus bt. B doesn't look very good. Let me try that again. Plus bt. And then z naught plus ct. Okay, so let's get the answers then. So my x would then be equal to? Here's my two like important numbers there. So it starts with a 3 plus 0t. Very good. I got y is equal to 0 plus t. Perfect. Z is equal to plus t. Good. Yep. Exactly. Like as far as what I was doing, I was just doing the numbers. So then I would say this guy plus this much t. And then I'd say that 0 plus -3t, right? So all these guys are with the t's because they're the slopes. Push them with the t. Do I have an answer up there that makes sense with what we have? You like A? Yeah, basically anything with a 0, you don't have to rewrite. Looks good. A, you got it. Cool. Awesome. So I was scared at first because it was like, right? There's just so much blah. But in the end, not too bad. As soon as we kind of know what they're wanting to say. That is most of the battle here. At this point, y'all are math professionals. So you know that the hardest part of every math problem is how to start. Literally the very beginning. What do I do? And that's for any problem, you know. So. Oh yes, I was doing that today in class. Yeah, that's funny. Yeah, definitely. So this one's a fun one. We might be able to do this in Desmos. I don't know. I don't want to rely on it, but there's so much that I could talk about right here. It's so fun. Let's see if Desmos will work, just so that I got it like a base of operations, and then we'll go from there. We'll expound from there. So will it do the 3D lines? So x equals no, x equals t times cosine of t, and we're gonna add the slider. Yep. Let's just keep on trying here. I don't think it's liking it. Okay, I know what to do. Parentheses. Do I have to use like this? Oh, parentheses. Yeah, I think so. And I don't know about the vector part being required or not, but let's just see what's gonna happen. I want like T slider. Yeah. Here we go. Let's go -10 to 10. It doesn't really matter. But now, yes, look at that. Ooh, very pretty. Okay, that's good to know because I don't pay attention. So let me do this. Now that I know, we can just type it in with the parentheses. It says t is greater than 0. So we'd want to start at 0, and then let's do 100, and we definitely got the right answer now. Like, which one is it? B, clearly. Yep. Let's check it. And yep, we're good. So there is a backup plan, right? Backup plan. But oh my gosh, there's so much fun stuff to. Is that the last one of the Yeah, there you go. So we got plenty of time. I'm not going to go. Well, I might actually go 15 minutes on it. We'll see. But I want to get a blank page, and let's talk about how to do that by hand. It is important later, obviously, and it's not just for a multiple choice. It's just to know what to look for. So let's start with some basics that we all definitely know. Okay, x is equal to r cosine theta. Y is equal to r sine theta. Yes. If I were to represent this in a shape, a 2D shape, what would that look like? Give me a name. Where did these come from? Circle. It's the unit circle, right? Where do those formulas come from is unit circle stuff. Yes? This is when we were learning unit circle. So I'm going to say that whenever you have a vector with a cosine and a sine, something like that, this dude right here is circle-y. Okay? I don't want to write a Y. That kind of looks weird. It's a circle. Now, what if I did a 2 in the front right there? It's not a circle anymore. What is it now? Yeah, exactly. Ellipse. You got it. Exactly right. It's an ellipse now. I'm making my radius, my r, a little bit bigger in some cases, bigger x's, smaller y's. So this will be a 1, but this will be a 2 distance now, right? So one of the keys to looking at these kind of problems is look for a pair of cosine and sine together. Okay, it's a very, very common feature when we're looking at this stuff. Okay, where's my eraser? So we're looking at sine and cosine together. Do we see a sine and cosine in this case? It's right here. Cosine and sine. So right now, this chunk of it is telling me that we're going to have a circle, and specifically starting at 0 and going counterclockwise. Very important there. What if I had started with a sine and then a cosine? It actually starts at north and goes clockwise. So that's sine and cosine. But that's trig. It's been a while. I'm just reminding you that kind of stuff, okay? Cool. But notice that this one's a little different than what I had because it has a t for its magnitude, right? That means the more t, the more time I'm going to be spinning around, but the radius gets bigger. And when I start, what's my radius at the very beginning, technically? T equals 0, radius equals 0. That's at radius stuff. So then I'm actually starting here at the very beginning and going vroom around. But then I'm going to keep going, right? What you've just discovered, this guy right here is a spiral. Is a spiral. Okay? So we're looking at it 2D, looking down, it's a spiral. And already you can probably guess one of the answers. I know this guy's a spiral as well. So we're going to go a little bit further. Okay, so that's a variable radius. And sometimes they'll even invert it. They'll do like 1 over t. So then it starts big and it goes into the inside. And that's probably what's going on with this guy right here. To me, it feels like it's going up to a point, getting smaller, but I might be wrong. That's a whole. It depends on what direction you're going. So the last one. Let me rewrite this stuff, and we're gonna see more of this as we keep going. We have to be able to see it and kind of do something with it. Notice that my z is linearly proportional to its to the radius here. Yes, as in like these guys are all the same essentially. Even if you put a 2 right there, it wouldn't matter because they're about the same. Okay, and so as much as I go around, right? As much as I go around in a spiral, it's also going up that much. And so 3D, I start here, and I would want to go just around here and, be done with a circle, right? And then I would like kind of spiral out, kind of like what I'm doing here. But then I'm not growing any. That's not going up. I need to go up with that. That's just a shadow. So I'm going to go up with it. See? Now it's a tornado. Tornado. Um, so it's kind of seeing commonalities and stuff. Here's an interesting one. What if I had not 2t? What if I had t squared? What's now going on with the height? Dramatically. It's not just a normal tornado. That thing's like a whirlwind thing, right? Another one. What if I didn't have t squared? What if I had e to the t? Even more. Even more. What if I had e to the negative t? So it would get smaller and smaller. Spiral. I mean, I'm not perfect at this, but like here's the flat plane. I would spiral, and it would just kind of keep spinning around there, kind of probably like this guy, right? Fun. I love talking about the relationship between these variables because they all have different ways of expressing themselves. So then it would go with it. So I'm not going to be perfect at drawing it. I'm going to try here. So you're saying, and it does happen. That's a very common one too. Sine, cosine, sine. So this is my circle for sure, and it's easy for me to keep the xy as that. But then my z is the same as my x. So then if I had a circle, let's just do a circle here. There's no spiral here. So yeah, let's just do a circle. Well, then when I do my z, again, I'm doing a circle on the xy plane. So I'm just, normal plane there. My z would be another color. Give me a color. Give me a color. So this is x, this is z, and they're the same. So I would actually be here a little higher. See how my x is like 1? So my z would be 1 technically. But then my x is 0, it would come down and then would come back up, and it would be a circle, but it's like rotated. It's kind of like a Saturn or something. Yeah, like if you were looking, if this was y and z, it would kind of look like an ellipse, I guess, because it's not directly. But if you looked at it straight x and y, it would look like a circle. So it'd be still a circle this way, but it's kind of more elliptical because it's kind of bending a little bit. Oh yeah, definitely. There's nothing wrong with that. It's really cool. Okay, well that took me 5 minutes, so let's keep going. Yeah, there's so much fun stuff, and the WebAssign class used to like have a little bit more emphasis on that, and they would have, you know how we had that one section 12.6 where it's just a bunch of graphs. So they had one of those like this, a whole bunch of graphs. Find which one's going on where. So fun, but we got to keep moving. So integrals. So derivatives were easy. Now we can do integrals, and they're easy integrals. We're not going to do anything crazy here yet. So, so integral of r dt, and so we're just integrating here. What would an integral make, right? So like if I had r and then I took a derivative r prime, now I got velocity. If I took another derivative r double prime, I got acceleration. But what if I went this way? What do I get? Okay. That sounds Newtonian.
Oh yeah, well, I'm making joke because you move it from up top to the low, since you go the other way.
Well, okay, so actually in Leibniz terms, you actually have to do a capital letter. So it goes from lowercase to capitals.
Okay.
If you're wanting to be really technical.
Yeah.
But yeah, thank you. That was a funny joke. What you're getting is something that you don't really know, actually. Right now, what we're going to probably do is just go backwards like this. But this is the basis of line integrals. I mean, isn't this a line right there? And aren't we integrating? But now line integrals are literally chapter 16. We're not going to get there today at all. So, but in a way, and this is not exact, but keep in mind, integrals is area underneath the curve. Yes? So let's take a curve and let's just go out. And I want to know what kind of shadow it would have. And so that area for that shadow could be, I'm going to say could be the integral there, okay? It's just as if it were 2D, now it's 3D. Yeah? That's all conceptual, and I'm definitely not going to stick to that because line integrals are not necessarily the area underneath the curve, but it's a concept, okay? It's a concept. Okay. I don't even know why I put this in here, but it looks cool. Oh, because the projection stuff. Right. So if you have a projectile and like eventually it collides, we need to find how high did it go, how far did it go, and all this. There's going to be formulas for that here pretty soon. Yeah, this one's super cool for finding all that stuff. There we go. Formulas, just like I thought. So we're going to, oh, look, and they're not starting at 0. That's kind of nice. Actually, it's terrible, but like we'll figure that out as we go. Yeah, to not start at 0 is important because this is where the cannon actually comes out. You know what I mean? I'm gonna make a cannon, or below you. Man, let me tell you. So this is really important to the Navy, obviously, right? They got the big battleships. They'll send missiles like inland, like miles. Oh yeah. Oh yeah, yeah. It's kind of interesting because like artillery, I'm not really into all that. I don't really know, but like we have a lot more drones nowadays. So it's more of, I guess it's easier to do less math, if that makes sense. But yeah, there's still use for this, of course, very much, of course. Okay, so it says just do the integral, and they're just like saying, hey, can you integrate? Yeah. This one? These formulas. Oh, okay. Yeah, I don't know. We probably won't use them today. So they just say find the integral. I don't want to go too crazy, but I mean, we could do this. What's my integral of this guy? Y'all are like already doing it. That's good. This guy? 6t, yep. And then this one? Yep, t squared over 2 plus 2t. And I have a different way of thinking, but good. Good nonetheless. I like your fractions in the front. Who'd you learn that from? Not me. You learned it from Larson? She's good. Everyone has a different flavor, you know? But here's the problem, guys, and, you know, I just want to be silly with you for a second. You didn't put plus c. So in Calculus 3, we do plus c, but we do plus c vector because there's 3 different c's going on, right? So yeah, that's what we would have to do. Now I know you're thinking, no, Chad, it's a definite integral. Exactly, I know, and we're for sure. You're right. I know you're looking. You're like, all right, Chad, but you're wrong. No, I know. But like later, we will have it where we have to do C, like it's a bold C with a little vector thingy, that kind of thing. Yes. So in this case, it's a definite integral. We're doing this thing now. Have y'all done that? The such that bar? When? Okay, good. Okay. Okay, we're good then. So I'm gonna plug in the 1, and then I'm gonna plug in the 0 after that. So I'm just gonna do that right quick. 1/2 plus 2 minus, and then we got each one and plug a 0 in. There we go. It's kind of silly, I know, but yeah. And notice how I'm approaching this problem, right? I write them on top of one another. What is that going to be? 3 5/2? 5/2. That's my answer. I write it on top of one another so I could like subtract them when I need to, that kind of thing. Let's just verify. I do it right. Did I pass it? Oh, there we go. Okay, cool. Yep. Sweet. Sweet. So integrals are easy, right? At least at this point. I don't find a lot of terrible integrals in Cal 3. We will have the occasional arc sign, and we have an arctan once in a while. Those are the 2 that might come up, but I'm not too worried going forward. And yeah, there'll be the integration by parts occasionally and whatever. We'll see. Okay. Oh yeah, I can go back. Yeah, I'm fine. We're cool. I know. You're good? So I know we only have 2 minutes. Ooh, look, we're doing differential equations. So I want to do it, but it's only 2 minutes. Are y'all okay if should I stay longer or should we just cut it short? Cut it short, or keep going? I'm gonna cut it short. It's okay. I'm gonna this is a cool thing, but differential equations has been forever. We'll see it next time. Thank you guys.